Good morning, everybody. Thank you. If this place is for someone who uses Lua language as an expert, who have already achieved many interesting development, maybe I should say that I'm not an appropriate person, because it is only several months that I discovered the language and started learning and starting developing. But if this place is also for someone who find the language really interesting and who is willing to exploit the language while applying many application domains, yes, I am. My name is Min-Jung. Thank you very much for giving me this opportunity of presentation. And so my presentation is composed of the following elements. First of all, please let me introduce a bit myself. And then I should present a bit the background story of our development in Lua. And then the third point concerns the context of the world, because this project is funded by another big project. And then the last three parts concerns my impression and maybe my challenges in developing Lua. And then I will conclude my speech. So I'm a scientist at the School of Engineering and the Swiss Federal Institute of Technology. I'm working for the engineering department. It is about more than 5 years that I'm working for 3 different laboratories. Firstly, I developed supply chain and production simulation and optimization completely in Java. So I'm an old programmer in Java. Okay. And then the second laboratory concerns the computer-aided design and production. So I'm also in the context of production. And for this laboratory, I'm working for the product life cycle management. And then the final point is the most important context that I would like to share today. I'm working for the laboratory for industrial process and energy systems engineering. What does it concern? So in our laboratory, we have already previous work for the purpose of optimizing energy use in the industrial processes. But it is not myself. The whole system was developed in MatLab. And one day they decided to get into Lua while completely re-implementing the existing methodology and adding some important and interesting aspects. The first problem that they have got with the MatLab-based platform is the performance matters. The simulation of industrial scales concerns many data and very complex algorithms. They are struggling with MATLAB in terms of memory use and then the time of computations. By the way, MATLAB is a good tool. MATLAB is a good platform for such objectives. And secondly, they would like to distribute in a free manner to many industries and other academics. But at that moment, they have huge problems with the MATLAB licensing. So before entering into the details of our proper project, I would like to introduce a bit the industrial processes and their energy efficiency problems. But I would like to leave the place to our colleague who will present the details in this matter. So I would like to just introduce the global context. What does it mean, energy efficiency? It doesn't concern only to reduce the energy use, because when we look at into the city, maybe while doing some industrial processes, they are using energies, but they are also producing some heat. So from our point of view, energy efficiency concerns also the heat recovery and then use waste heat for other purposes. The waste heat for example, district heating. That's the reason why in general, our energy model include the energy use model, but also energy distribution and the reuse from other processes. So in order to optimize in such a perspective, the previous platform called Osmos in MatLab was developed. I don't like to bother your time with such a complex schema. So please let me introduce only the general schema of the methodology developed in MatLab. First of all, on the right side, on the top corner, there is the model. The model is implemented, described using some MATLAB code, and it runs another more specialized solvers which was provided as external software. And then once again, in the context of each energy model, it is the economic models and a small set of life cycle assessment modules, which was already hard-coded in MATLAB. And of course, as the energy integration is not the whole thing to do. We should also economize the economic methods, such like the cost of running some energy generations or some economic methods. And the whole global optimization was also achieved on other more specialized tools. So now let's move on to the transition phase. So the re-implementation in Lua was completely achieved, and this will be presented by next speaker. And from my side, I would like to just talk about the extension to another additional dimension. For example, more towards a more holistic approach, including GIS functions and environmental impact analysis and the database functions. So let's move on to the center of this work. More concretely speaking, adding more dimension means giving the capability of covering general issues in industrial processes. For example, what does it mean biomethanation, or some what does it mean the wastewater treatment, and where does all the waters go, and something like that. And then we also want to add some supply chain dimension, and including some graphical notations, such as longitude and latitude of a building, or the distance to be covered by the transportation, by some trucks and trains. And of course, one of the most important thing is to add the life cycle assessment and their analysis. And nowadays, the matter of environmental concerns become more and more important. So that's what we tried to get into our existing methodology. So the context of the project, let's go a bit the details. The project called PF3 is partially funded by the French development program by the French National Agency. So it includes, as the consortium of the project, several industrial partners and several academic institutions from France. And EPFL is the only French institution who is participating in the project. And at the end of the project, of course, there should be some specialized user interface, which will be managed by the project coordinators. By the way, our Lua part will completely be on open source. That's the reason I would like to share as many things as possible. And okay. So what should be the role of the extended LUA part energy integration model? It should be the backend system for simulation, analysis, and the optimization. And the user front end is partly modeled in, because there are several partners and they have different specialties. And the user front end should be in C+ or Java, and including some open standard GIS tools. And we have, our partners are testing 2 different tools, and finally, they will find one thing to be integrated with LUA. And this, the right part is the existing LUA module. On the top corner, that concerns the translated generic energy integration model, and the bottom part concerns some studied in add-ons and some generic functions developed in LUA. So this is the whole implementation architecture. I'm sorry for the complex slide because I prepared it as using the PowerPoint animations, but as we have some trouble by leading the animation slides, I regenerated it as a PDF, so it is a bit too charged. So on the top corner, the top corner present the yellow one, present our generic model. For example, the car, electricity car, or natural gas, or generation of natural gas, building, everything can be represented as a generic model. And which is interesting in our implementation, actually ongoing, is that we could generalize the corresponding LCI factor. If it concerns a car, how many CO2 will be diffused in the air concerning the user 1 year, and if the car is running 3 hours for days and something like that, it can be integrated almost automatically. And then on the bottom part concerns the LCIA metatables, because LCI is a fact. Yes, there was some diffusions. But how harmful it is from within 10 years or in our health, well, how harmful? To what extent it is harmful? It concerns the analysis phase, and there are many methods, many categories of indicators which are already studied. So we have selected some outstanding methodologies, and they are integrated as in terms of metadata, and the red parts are written completely in Lua. And then this part is our ongoing work. And the geographic location should be integrated as the one of parameters or variables of our generic ET models. That means modeling 2 buildings and simulating the energy generation and energy integration in Geneva should quite be different to simulate the same elements in Moscow. So that's the reason why we would like to maximize the reuse. But in a different simulation and a different economic context, while running some transportation means by train or by trucks, the cost should quite be different between Geneva and Moscow. So that was our vision in extending Osmos Lua while adding some other features. And finally, we would like to associate some database, because on the one hand, in order to save all the possible generic energy systems model, and then in order to share some general parameters and economic factors which can be provided with the model. So I was interested in using Lua SQL while integrating SQLite, and as Progress SQL is not yet tested, but among the different things, I have some preference of using SQLite 3. So if you have a question, I will show some case study, but I don't think that it is very interesting for all publics. So let's move on to my personal opinions while developing such a thing. First of all, I appreciated very much concerning the Lua languages and its flexibility. But I don't know whether I can say so like that, so please correct me. First of all, adding new subsystems such as GIS Data Handler, SCI dataset integrations, or some other things, it was not intended to be from the beginning of the new project. In general terms, such an API extension cannot be done quite straight away. So, but what happens in general, existing system was not designed to be extended. That's the main reason. It is not limited to the Lua or some other languages. But from my point of view, Lua allowed me to do some object orientation without declaring the class. So I appreciated very much such a flexible possibility of structuring information architecture. And then secondly, the table management using Lua was quite flexible. It helped very much our development in terms of different variables and parameter management, because by the characteristics of the target system, we must handle many different types of data and attributes in a flexible way. Sometimes a dump of data is transferred from one part of the API to another part of the API while using a kind of data as the key. But in another part, the key was quite different. But we could change by a flexible ways the table structure, and the same data contents can be used differently. But we have many difficulties. As it is our first development in Lua, we have struggled many problems. Firstly, Lua is not a well-known language in our, at least in my region and in our school. So finding students and assistants step in development was a big problem, and even now it is. But it's wondering that in front of myself, there are many Lua developers and Lua specialists. It's amazing. So I'm certain that I will not have such a problem in the future. And the second small point, but important, promoting the project outcomes. When we introduced the idea of using Lua, most importantly, the industrial partners surprised them. What? Which language? Lua, L-U-A. They did, I don't know this language. So I had to ask them, do you know Angry Bird, the game Angry Bird? Oh yes, I am. And it is the language used for the development of Angry Bird. Oh yes. So with the grace of Angry Bird, we could make our industrial partners sign on the contract. So I should thank you very much. But by the way, I'm wondering whether there are just some previous participants into Angry Bird. No. And then some technical difficulties. But it's a good news. Already I could get some ideas on that. But for example, exploiting the resulting API on different machines, because we have tested some partial prototype in different machines and different operating systems. And actually, we have got some problems of using the part on Microsoft 64 bits. Because the first prototype of front-end developed in C and C++, they tried to call Lua, but on a 64-bit machine, a Microsoft operating system, we have some problems. But I think while testing Lua's 5.3, we have no such problems. And the possibility of bit operations is another good news, because due to the characteristics of our implementation, we need high precision in scientific numerics. Before, it was not possible. And in our previous method in MatLab, the modelers used the many bit operations represented as the MatLab table. But now we can retrieve many parts of the previous methods and algorithms in Lua. So that was good news for me. And that already a success. Yes, that concerns the Windows 64 bits, but starting from next week, I will test 5.3 with the 64 bits. So now, in order to get over with such difficulties, we are doing something in parallel. First of all, we created a new course in doctoral student programs, which is specialized in the section of energy, and in order to learning Lua and Osmos Lua. Because I would like to combine both aspects in our point of view. And the first series of this course will be given within 1 month. But by the way, may I ask you as invited lecturer of our course, maybe next 2 years? Just thank you. It is also a very interesting thing. And we don't hesitate to giving some technical support to Swiss and French industries and academics, of course, in order to promote our approach. So yes, why I dared to come here, because I would like to share and communicate with the community of Lua, with you, for everything. The results, yes, it looks not very great, but who knows, maybe our LCI and LCIA parts can be jointly used in your Lua program in some game. So in order to measure how much CO2 was distributed while doing something in your Lua model, because the part should be distributed as some add-ons, and I should use your Lua rocks. I know, yes. And we are very interested in exchanging academic staffs and students, so we are open. So please knock our door. And creating other industrial projects or academic projects, of course, yes, why not? So thank you very much for your attention. We are very happy to join the Lua community. So thank you. I'm happy to answer any questions that you may have.
Okay, so you came from MatLab to Lua, right?
Yes.
And MatLab has a lot of statistics, mathematical functions. It must have been very hard to convert all of that to Lua. How did you manage that?
That's a good point. So the whole model was developed in MatLab. By the way, do you have the pointer?
Unfortunately, not. Use your hand.
No problem. So in the middle side, there is the model part, external software. That's the reason why we call some external software. I can mention some Cplex, GPROMS, or Modelica, or Aspen, in order to do such a scientific calculation. So when generating the, when implementing the methodology in Lua, we used the same approach. So the most scientific parts can be reused if we can reuse the external softwares using Lua.
Thank you.
Thank you for your very interesting presentation.
Thank you.
I have a question. Do you use Lua as a glue for some external high performance calculation software, or do you also try to perform some scientific calculation, maybe numerical simulation, using Lua by itself?
Before, I should be honest, before we didn't think much of using Lua for proper computation because we have limited by many variable types which cannot be subtyped, and some operating limitations. But now I'm thinking of it. And most importantly, the LCI and LCIA parts can be modeled while associating some proper algorithms, because the LCI and LCIA approach requires very high precision of data elements. But now we can do that. So until now, the optimization computing was not done by the Lua part. But in the future, in the very near future, I think it should be possible.
Then another question.
Yes.
MATLAB has not only libraries, but its language itself allows to use effective array operations. It's convenient for the programmer, and it's very fast because it's coupled with state-of-the-art solvers used in Fortran, C and C++. And do you plan to use some syntactic extensions to Lua to do the same things?
I see your point. And as a bare programmer using MATLAB, yes, MATLAB provides some very convenient library mechanisms. You are right. That's the reason while transferring in Lua, our colleague Hono tried to give some middle layer language in order to the Lua part to be more convenient and easy to use as an energy model representation. So it will be seen, I hope so, it will be seen during the next presentation. And then secondly, specifically in the context of the project PFE3, the other partners are working on additional layer in order to be appropriate for more general terms. So it is already, if we can go at this kind of layer, it should be very different to develop something properly in MATLAB. It should be more easy and more clear in terms of industrial processes and energy systems optimizations.
Okay, thank you.
Thank you very much.
I have a couple of quick questions. You mentioned your source code that was available. So where I tried to Google it and didn't find it quickly.
Yes, the source code is available, but the method and the mechanism has been implemented. And by the way, we have a very small set of generic models, but I can also mention that natural gas generation and 2 or 3 types of car model, electricity and petrol car and gas, natural gas cars, and then some typical industrial processes. And the model should, if you are not interested in really modeling your own energy systems, it is available. But a weak point, it is not distributed using Lua rocks. So if you can find a couple of weeks, I will create a Lua rock server. But otherwise, I can diffuse it by mail.
Okay, so
yes.
It's not published yet.
Not published yet.
And you mentioned databases. You store your data in databases. How you access databases from your project? What databases you use?
Yes, so you mean the SQLite 3? Or something like that. Yet furthermore,
I didn't know, you didn't say what you use, so Could you tell a bit more about what you're using?
Yeah. So the database is created once the user creates its own energy components and the simulation to do. Then already the simulation concerns for the moment they are the copy. It is permanent. It is on a working runtime environment. And once the models its energy systems in a district, and then if it starts running, we can know now what's the variables, what's the parameters, and what's the model itself, and what should be the output to observe, for example, operating cost, the total CO2 emissions, and something like that. And each element is provided by a specific tag. For example, concerning the outputs, the mean operating cost or yearly operating cost, there are some predefined words used in our Osmos Lua part, and plus there is some the keywords such like longitude, latitude, which are coming from the GIS system, and then all the database is saved in SQLite 3. But furthermore, the user doesn't select some parts, so it is a huge database. If one runs only one time the simulation, there is one line which concerns every element. But if one should run, for example, 100 times, that was the test that we have done with an external tool, which called MatLab, Dakota, excuse me. Dakota, in order to do some sensitivity analysis, we run the same model for 100 times. In that case, we don't save the data in the database because it becomes too big and unuseful. So in that case, we use only the reporting came from the Dakota.
Okay, thanks.
My first question is about conversion of the code to Lua. The typical MATLAB code uses vectorization very intensively. How it was converted to Lua?
So I should first of all say that the MATLAB code of Osmos, previous version of Osmos, is already a template. The user should specify his part of model using some specific tab like parameters 1, 2, 3, 4, and variables 1, 2, 3, 4. And then there is the core energy model part, which should be explained by the means of temperature or some streams of electricity or the streams of water or something like that. So they have already been categorized for the purpose. So what we could do in order to generate our libraries of ET model, I should first of all select the parameter part because there is some function developed in MATLAB but associated to MATLAB Osmos. So we can first of all extract the parameters and we can extract the variables. And the other part, in order to transfer the energy integration, for the moment it is by hand.
What are the advantages of the conversion to Lua over the MATLAB coder and MATLAB compiler?
I should say there are 2 points of view. First of all, technical points of view, and then secondly, the strategic point of view. It's, I guess, but they put the 50% and 50% weighting factor on both sides. For example, MATLAB should be distributed among the users who have the license. In 90% of the case, our partners or future partners haven't got such a license. We have the license as an academic user, but we cannot distribute the output. Though I think such a strategic point was very important. Lua is an openly distributed language, so we have no such problems. And then technical points of view, yes, C and C+ is also quite runs quite fast. And honestly speaking, Java is better known in the society. But from my point of view, Lua is interesting in terms of it is the language which can be used not only for development as a C-like structure, but also can be used as a script language. That's the important point. Because without adding some other layer of script language, we are applying Lua on both sides.
Thank you.
Okay.
Thank you very much.
But I have a question.
Oh, sorry.
Okay, so you said that the code is open source but not published. But what under what license is it available?
As for the license on the part of Lua Osmos, I would like to leave the place to Honor, because it is the same license. For the moment, it is the same license as Lua. Yes.
MIT.
Yes.
Okay.
Yeah.
Okay. Another question. I believe that there is a scientific computation library in Lua called GSL Shell. Did you check it out?
No, not, but I checked the another libraries. I don't remember the name. It is a bit like the Python scientific libraries. But thank you very much for your information. I'm interested in looking at it. Thank you.
Okay.
So if you have another comments, as I'm a newcomer, I'll be happy to discuss with you. Please give me your feedback, your ideas. I would like to take advantage of your wonderful experience.
Have you tried LuaJIT?
So
the JIT compiler for Lua, LuaJIT.
okay, thank you.
Okay, but what version of Lua do you use?
Sorry?
What version of Lua do you use?
For until SQLite 3, I used the 5.1.
Okay.
I didn't yet test it with 5.2, but I give up this idea and I'm jumping on the 5.3.
Okay, but the problem here is that LuaJIT is 5.1. So you may want to try LuaJIT first and then 5.2
Okay,
and
thank
3.
you.
Okay, so any more questions? Well, Roberta corrects me. LuaJIT is not 5.1, but it's a compatible dialect. Is it okay?
In one direction.
In one direction. Yes, but it's still. 5.1 is compatible with LuaJIT, and LuaJIT is not compatible with 5.1. That's true.
For Lua 5.1, I mean, if you have code for Lua 5.1, it runs in LuaJIT. If you have code for LuaJIT, it doesn't run in Lua 5.1.
But you don't have to write code for LuaJIT to use LuaJIT.
Then
so
you have
can still be compatible and benefit from speed.
Most code for 5.2 runs in LuaJIT.
Yeah.
Yes, two.
Okay.
Yes, I have many works to do.
Okay, so thank you.
Thank you very much.